Okay, in today's video, I am going to go over what is charge. Now, I'm not going to go over how to calculate the charge or what the charge on capacitors is or how you calculate that. I just want to go over in general a conceptual idea of what charge is. The definition of charge, the units, the abbreviations, how we talk about charge, just so that you, when you're doing problems with Ohm's law and doing calculations with capacitors, you have some general idea about what charge is, because there are several terms that you should be familiar with. Charge is one of them. Another is current, resistance, capacitance, and voltage. And a lot of times I see people doing calculations, getting the right answers, but I'm never quite sure that they understand exactly like what is charge or what is current, especially when you're working with, like, for example, Ohm's law, V equals I times R, the voltage equals the current times the resistance, or what I like to call the capacitor equation, Q equals C times V, charge equals capacitance times voltage. What is charge? That's what we're going to talk about, so you have some idea when you say an object has a certain amount of charge that you know what that is. All right, now what is charge? Well, charge is just the physical property of matter. An object can be charged, just like it's a physical property, just like color or density is. And an object can be negatively charged or positively charged. Well, how do we get an object to be negatively charged? Well, we get an object to be negatively charged by adding electrons to it. Electrons have a negative charge. Okay, well, how do you get something to be positively charged? You don't add protons. What you do is you take electrons away. So if something is positively charged, you've taken electrons away, and therefore there are more protons than electrons. If something is negatively charged, that means you've added electrons, and there are more electrons than protons. When something is neutral, then it has the same number of protons and electrons. Okay, the protons being positive, the electrons being negative. Now, when we talk about charge, or when we use charge in our equations, the symbol we give to charge that has been given to charge is Q. The symbol for charge is Q. Q equals C times V. Q is charge. Okay, it's not the C in Q equals C times V. That's capacitance. In the equation, Q equals C times V, Q is charge. The metric unit for charge is the coulomb. All right, named after a French guy, Coulomb. And we abbreviate that with a capital C. So the symbol is Q, the metric unit, when we measure it in coulombs, and we abbreviate that with a C. So for example, here you can see we have charge equals, for example, 0.5 coulomb. Now we can abbreviate that as Q equals 0.5 C, or we just say charge equals 0.5 coulomb. Or we have, for another example, Q equals 12 microcoulomb. Okay, usually we have less than a coulomb, and usually we have much less than a coulomb, because a coulomb is a lot of charge. All right, so this is 12 microcoulomb. Now, I want to point out, in science class, especially when you're a freshman or something like that, we say an electron and a proton have a charge of 1. The electron is -1, the proton is -1. That's not really the charge of a proton-electron. Protons and electrons have a much smaller charge. It's 1.6 times 10 to the minus 19. Now they both have the same charge, it's just opposite. Electrons are positive, electrons are negative, and protons are positive. Now they have the same charge, so we can just call that basic unit of charge, which that is the basic unit of charge, the charge on an electron. That is the basic unit. We can just call that 1. Similar to atomic mass units. Okay, the mass of a proton, the mass of a neutron is the same, and we just say, well, that mass is 1, because that's our basic unit of mass. Well, this is the charge. The charge on a proton, the charge on an electron is really 1.6 times 10 to the minus 19, and that's kind of our basic unit. So we say the charge on a proton is +1, the charge on an electron is -1, but it's not. It's 1.6 times 10 to the minus 19. Now that's a pretty small number, and if you want to have 1 coulomb of charge, okay, a coulomb is an amount of charge. If you want to have 1 coulomb of charge, you have to have 6.2 times 10 to the 18 electrons. That is the amount. If you take this number times this number, you get 1. Okay, so in order to get this number, I took 1 divided by this number. How many, parts are there in a whole? Well, there are this many parts if you want to have a whole unit. Okay, so 1 coulomb of charge is 1.6 4 times 10 to the 18th electrons. Now let's just look. What if an object has a charge of 12 microcoulombs? So for example, if you have an object and it has a charge of minus 12 microcoulombs, what does that mean? How many electrons is that? Okay, so we're now going to just do a quick example, quick calculation of what 12 microcoulombs is. Because you see problems, oh, the charge on an object is plus 12 microcoulombs, or the charge on an object is minus 12 microcoulombs. Well, what does that mean? It's some number of electrons we're talking about that have been moved around. So we're going to take 12 microcoulombs and we're going to convert that. And we're going to convert that into coulombs first, because we know 1 coulomb is 1.6 times 10 to the 6 microcoulomb. So we want to get rid of this unit. We want to cancel the microcoulomb, cancel the microcoulombs. Now our answer is in coulombs. Okay, and that's like going from meters to millimeters. We're going from microcoulombs to coulombs. Now we're going to convert that into a number of electrons, because we know that in 1 coulomb there are 6.2 times 10 to the 18th electrons. So now you can see, if we do the math, we have coulombs are canceled, microcoulombs. Then this coulomb cancels with this, and our answer is in electrons. So if we do that, you get that that is 7.49 times 10 to the 13 electrons. So if you're doing a problem in your physics class and you have an object and you're trying to calculate the force, okay, with Coulomb's law, and you have an object that has 12 microcoulombs of charge and that's negative, that means that means that 7.49, okay, you can't have a fraction of electron, but 7 times 10 to the 13 electrons have been placed on that object. If it has a positive charge, then that means that that number of electrons have been removed from that object, or there are that many more electrons than protons. Okay, so that's I just want to give you some idea of what coulomb is, and when we talk about a number of coulombs, really what it is. It's really a number of electrons. Okay, so thank you very much for watching. I hope you found that helpful. If you found that helpful, you can give me a thumbs up or a nice comment in the comment section below. Thank you very much for watching. We will see you in the next video.